welcome to Chemistry 410. This is the thermal decomposition of tert-butyl ammonia borane. So to begin, we need to assemble our apparatus here. I've got a 250 milliliter 3-neck flask here clamped up. It already has a stir bar in it. The first thing we're going to do actually is I've got our 3 grams of tert-butyl ammonium chloride right here on the balance. So I will take that over and go ahead and put that in our flask. Along with 15 milliliters of THF. Use that to kind of rinse some of the powder out of the joint. So our next step is going to be adding a few things here. So we're going to add a septum to this side. And you'll see why in a moment. These can be tricky sometimes, especially if they're new. Just hold the lip over. The middle portion there will receive this stopper, but we need to grease it first so that it seals well. So you'll see a syringe sometimes loaded with grease. If you don't have one, you'll want to use this Dow Corning high vacuum grease. That's what's in this syringe. And to grease the syringe, all we have to do is really gently push on the syringe and just put a sort of thin streak. I like to do 3, kind of, you know, in a triangle pattern. Just a real thin streak there. Insert and then twist carefully your stopper or implement here to get it sealed, and then we're going to use this rubber band here to hold that down. So as an alternative to an oil bubbler, in the case where nitrogen isn't available, if you're going to do the reaction under air, you can assemble a calcium chloride plug to prevent wet air from coming into your flask. So you'll need some kind of glassware like this. Angles work as well, just some way that you can stop up the entrance of the piece of glassware with glass wool in this case to prevent the calcium chloride from getting into your flask. So I've already stuffed this with glass wool, and then you'll want to use anhydrous calcium chloride. This one is specifically for desiccators, or in this case a plug. So these larger granules are helpful because they don't fall through the glass wool quite so easily. So we'll take our piece of glassware here and just kind of pour in these calcium chloride pellets. And that should be enough. And then we'll take our spatula and kind of tamp them down a little bit. And in this case, since this one will sit vertical or nearly vertical, we don't need to put anything else in the top of it. There are other types that have kind of a bell shape, and you'll need to put some kind of either more glass wool to pack it to retain the calcium chloride, of course, so it doesn't fall out, or rubber stoppers with a hole in them work as well. That's also done. So now we're going to assemble a gas inlet for our apparatus here. So that looks like this. And we need to grease this area here where the key will go in, which is the valve that controls the airflow, and then of course the ground glass joint for it to interface with our flask. And then this piece is what we call a key. So it has a small hole here that will allow for the gas to go through there. So we'll start by greasing this. And this will just take a little bit. We'll put 2 little streaks on it there. And we'll take our gas inlet piece, stick it in, give it a couple of rotations, and then you want to line up so if this stick, the handle portion of the key is lined up with the valve, then it's opened, and if it's perpendicular to it, then it's closed. So we'll leave that open for now. When we turn it over, we have this little metal clip here, which has a wide side and a little smaller, narrower side. The narrower side will go up, and you'll have to kind of, there's a notch in the back of the key. You want to force down that clip so that the narrower side catches under the notch of that. Like that. So now that our key is retained and it won't fall out while we're using it. So now we will grease our ground glass joint here. Should be just fine. Just kind of a little bit here and there. We'll insert it. Get that rotated so we get a nice seal. And then we also want to attach some rubber bands to keep it there so that it doesn't pop off while we're using the apparatus here. And I'm going to use two. Different clamps will give you more options for positioning of your rubber bands. So that should be good. And then the last piece here will attach is the hose here that gives us our nitrogen. You want to be careful pushing on these so that you don't break them. And the next thing we'll do is attach our bubbler here to the septum. Alright, so to complete the circuit, we will need to attach a bubbler, and we'll attach that to the end of the septum here. So an oil bubbler allows gas out but not into our system. So to connect that, we'll take a hypodermic needle, attach that to the end of the syringe that's been mounted in this tubing, and insert that into our system here. Sometimes it's a good idea to clamp this tube up out of the way so that it doesn't strain the needle or the syringe. So once your bubbler is in place, we can turn on our nitrogen. Up here again, the valve at the top left of your hood, or top side of your hood. You can see our flow, so we don't want it that high. So we'll watch that bubbler over there. That's the out bubbler for this line. That seems to be a good right there. And then we'll put this valve up here so we can make that visible. This valve here will turn upwards. So you may have to adjust your nitrogen flow to get it to bubble through your bubbler and through your system and through your bubbler. So while we're purging that flask with nitrogen, I weighed out the sodium borohydride that we need for the next step. So I've got the 0.2 grams here. Take that off the balance. We can take it over here and we will remove the stopper here from the top. Just set it there, convenient will stay. I've got a dry funnel here just so that we can get it past the grease joint so we don't have powder sticking in the grease. And we'll add in our sodium borohydride. That down off the funnel with another 10 to 15 milliliters of THF. I've got about 12 here. Alright. Once that's added, I'm going to go ahead and turn off our nitrogen flow. Should be okay now. And close this. Anyway, and now we can see the hydrogen that's being generated is what's pushing the air out of the system, the gases out of the system. So this will need to now stir for 2 hours, and then we'll be back for the next step. So our stirring time is complete now, so we're ready to move on to the next step. So we're going to filter this. So we'll turn the stirring off and remove our gas inlet. Make sure the nitrogen is turned off. We can also remove our bubbler. Be careful with the needle here. Tuck that out of the way. Now we'll remove it later. This over here, where I've got a round bottom flask set up with a fritted funnel. And so we'll start up the vacuum. So we're going to be retaining the liquid this time, not the solid. So we got to go evaporate off this solvent now, which we'll do with the rotovap once we've pulled off. Once we've filtered off the solid. Alright, so I'll let that filter through, and then I'll bring us back when we're ready to get this on the rotovap. So here's our solution. Take it over to the rotovap here. So that's one of these devices. We have 3 here in the lab. I'm going to use this one since it's connected to just one pump. So I've got our flask of solution here after pulling out from the filter. And I'm going to attach it here to the rotovap. So this here is a water bath, which I've got set to about 35 degrees. We'll be collecting our solvent in here, and we'll want the solid that will end up in there. This is a trap here to protect the vacuum pump from any fumes. And then over here I've got a bucket with water for the recirculation for the coil here for the solvent to condense on. So first we will close off our vacuum. We got to close this valve up here at the top to seal it for vacuum, our rotation, and turn on our vacuum pump. Alright, and when that's pumped down, we'll be ready to do the next step. The solution is boiling now, and we'll have it evaporated off soon. So I've got our flask of compound here from the rotovap. We've got sort of this colorless film here on the inside of the vial of the flask. So I'm going to add to that. I've got a few milliliters of toluene in this vial here. I'm going to add that to our flask here. And dissolve that. We'll stir around, should get it. I don't think we'll need any more toluene. Can't get it to dissolve after a few minutes, then you could definitely use some more toluene to get that all to dissolve. Maybe we will need more toluene. So now I'm going to pipette this off into the vial here so that we can see the next step a little bit better. so now I have in this graduated cylinder 20 milliliters of hexanes. This might not all fit in this vial, but we'll see how much of it we can add before it overfills. And they're doing this, adding the hexanes to our toluene solution to precipitate out our product. And it gets nice and cloudy. So, didn't quite get it all, maybe we can. Yeah, pretty close. Okay. So there we go. You can see we got precipitate forming there. That'll be our product that we'll collect. So we'll get set up for filtration. We can collect our product here. Alright, so we're set up for filtration now. So let's pull our vacuum here. We'll take our vial of compound. Try to slosh it off the sides of the vial here. Alright, we'll dry that on the filter for a little while, and then we'll be ready for the, well, after you dried it on the filter, you would weigh it, collect it and weigh it, and then you'd also want to get a melting point. But I'll be showing you the decomposition reaction next. So now I'm going to weigh out a portion of our ammonia borane complex to do the decomposition experiment. So I've got it here still in the funnel. Scrape it up. But before we get to that, what I've done is I've tared this balance here, and then now we can see what the mass of this vial is, and then we can write it on the side of it, or write it down in a notebook or something like that. You can take some of this compound here. So we're supposed to do between 25 and 45 milligrams. So there we have it, 32, almost 33 milligrams. So you would of course want to record this mass so that you know how much you started with and how much gas evolves after you weigh it the second time. So I've got this hot plate here heating up a little bit already, and I'm just going to set this vial here on the hot plate. Get it kind of spread out on the bottom to form a nice kind of even layer across the bottom of the vial so it heats nice and evenly. And we'll heat this, kind of crank it up a little bit here now and then until we start getting some gas evolution, and then I'll bring you back in and show you that part. So the compound has melted now. You can barely still see it even in the vial at all, so we should be getting close to where it will start to release some gas. I'm going to turn up the heat just slightly. See if we can get this to go. Here's a better look. You can see it bubbling there in the vial, and I can see some vapor, some kind of smoke vapor coming off the top there. Looks like there's a solid or something it looks like a solid kind of crystallizing again on the lip of the vial.
So I can still see a little wisp of vapor coming off, but this is where I'm going to stop the heating. The amount of time that you heat your vial is of course going to be up to you. So good luck with the experiment.
So I've got our funnel here with the solid remnants left in it here. I'm going to dump those in the solid waste. Scrape them out of the funnel straight into the solid waste.